We're going to start with number 4. The biggest thing about these double investment problems is that we need to think still that I is equal to PRT, but we just got to think of it in two different areas. So reading through this problem, we have ourselves 4%, and then I like to put it way over here, we have ourselves 1%. Okay, now how much money am I putting in the bank? Well, this number 825, that's the total we make out of both investments. So we're not going to use that till the very end of the problem. But at 4%, the problem says we're just putting some money in. Now we know we're going to the bank with 450. So the way we've been doing this, and hopefully it's starting to catch on, is that we just say we're putting some money at 4%. We just put in an X. That's the principal at 4%. Well, if I started with 450 and I subtracted a certain amount there, this expression is going to represent what I have left to put in the other investment. And that's one of the trickiest things for people to recognize, to understand. But here's the deal now. Since I'm using time as 1 year all the time for all these problems, I don't have to worry about the time. I basically just take the principal times the rate. Well, converting to a decimal, this side would be 0.04x. Well, that stands for the interest earned on this investment. And then over here, my interest earned is principal, which is actually 450 minus x. That's the amount I'm putting in the bank, times 0.1, times 1 for a year, which we don't need. So then when I distribute that through, I'm getting an interest of 4.5 minus 0.01x. And I just realized I put 0.1 here. That was like terrible of me to do in the video, but I'm not going to start over. Look at this. It has to be 0.01. Okay, 0.1 would be 10%. So 1% is 0.01, and I apologize for that. Okay, but here's the deal now. I have some money that I'm making at 1%. I have some money that I'm making at 4%. I need to add these two together. I need to take 0.04x, and I need to add to that this one over here, the 4.5 minus 0.01x, because those represent, this is the amount I'm going to earn here, this is the amount I'm going to earn over there. Add those together and I'll get my total earnings that the problem told me of 8.25. So that goes over there. All right, well now if you see I have x's, so I have some x's here and I got some x's here. So if I basically just do combine like terms, 0.04x minus 0.01x, just type that into your calculator if you struggle with that for now, and that would be 0.03x plus 4.5 equals 8.25. Don't forget your x on the 0.03. But now I'm trying to isolate the x, so I just subtract 4.5 from both sides, and I'm just solving the equation. So 0.03x is equal to 3.75. And then when I divide both sides by 0.03, I'm getting the x value of 125. Now don't forget what that represents. Let me switch colors here to green. How much should he deposit into each account? So over here at the 4% account, x was the amount of money I put in there. So that's going to be, for this problem, that's going to be $125. Over here, I put in the 125 for x, but I do 450 minus that 125. So to answer the question at 1%, that's going to leave me with $325 because 450 minus 125 is that. So these are my two answers to this problem. All right, I'm going to keep going. Hopefully I can you can see how this problem is very similar to the last problem, but it has to deal with juices and percentages. So here's the idea. I'm going to take 100% of pure orange juice. So I got OJ over here that's 100%, and I'm going to mix that with 20% of apple juice. But like we've been talking about in class, when you mix these two together, you don't get 120% juice. That doesn't make sense. You're going to have a 30% mixture. Okay, so this is the mix down here. So that's just the percentages. So one thing at play is the percentages. The other thing at play is how much I actually have. So it tells me I have 24 ounces of the mixture. So I start with that down here. I have 24 ounces. All right, well, what does that mean? Well, it means I don't know what I have here. I'm not sure, but this one over here has to be 24 minus x. Now again, let me do this and then I'll erase it. Look at this green number. If this is 24 and I put a 10 here, we would do 24 minus 10 to get 14 over here. That logic makes sense. So we again have to subtract the x to have that value right up there, okay? All right, so now let's actually figure out by writing our equation. Well, our equation comes from adding these two together to equal the mixture. It's kind of common sense. This one plus that one equals the mixture. So, switch to blue here for my equation. So I'm going to have 100% times x. Well, as a decimal, 100% is 1.0. So I have 1.0x. And then I'm going to add to that 20%, which is 0.2, times however much I have, which is 24 minus x. You just multiply these two numbers together. And that equals 30% times 24, so 0.3 times 24. So again, slow down and look at this. It's percent as a decimal times x times the amount you have. Percent times the amount you have plus percent times the amount you have equals percent times the amount you have. It's the same process through, it's just represented differently in each problem. All right, so here I got 1x plus, and then when I distribute through, I have 4.8 here minus 0.2x, and that equals 0.3 times 24, which is 7.2. So my first distribution through, now here I go away I solve. So 1 minus 0.2 is going to give me a positive 0.8x. Combine those like terms and I get 4.8 equals 7.2. And then I'm just solving. Just be careful not to make small mistakes when you're solving. 0.8x equals 2.4. And then when you get out that calculator and divide both sides by 0.8, you're going to get an x value that comes out to 3. Now don't forget what 3 means. 3 stands for the OJ. And the problem literally says how many ounces of a pure 100% orange juice. So they're asking about how much orange juice. So the answer is 3, and then obviously ounces. Okay, if they ask for how much AJ, that would be 21 ounces because you would subtract.